Now that we've explored how to simplify square roots with numbers inside of the radical, and we've also figured out how to tell if a variable expression is a perfect square, let's figure out how to simplify radicals that have both numbers and variables inside the radical. Let's first consider the square root of 9x squared. Remember, a square root is not considered to be in simplest form if it has any perfect square factors. Notice that there are two factors inside of the radical sign here. Recall that factors are things being multiplied, and the 9 is being multiplied by the x squared. So those are factors. 9 is a perfect square because the square root of 9 is 3, and x squared is a perfect square because the square root of x squared is x. So this square root is not considered to be in simplest form. To simplify a square root, factor the expression under the radical into perfect squares. Taking a look at this, 9 is already a perfect square, and x squared is already a perfect square, so that step is done for us. All that's left to do is apply the root of a product rule. That rule states that the root of a product is the same as the product of the roots. So I can take the two roots and multiply them by each other without changing the value. This allows me to write the square root of 9, which is 3, times the square root of x squared, which is x. This simplifies to 3x. Now, if you're not sure how to get the square root of x squared, just ask yourself, what times what will give you x squared? In this case, it should be pretty obvious that x times x should give you x squared. If you're still not sure, you can do this. The square root of x squared is the same as x squared, and the square root tells you to raise the expression that's inside the radical to the 1/2 power. So this is the same as x squared to the 1/2 power. Here I'm raising a power to a power, x squared to the 1/2 power. When raising a power to a power, multiply the powers. This gives me x. 2 times 1/2 is 1, or x to the first. So this leaves me with just x. So the square root of x squared is x. You can use that procedure anytime that you're simplifying a radical. Let's take another example. Let's consider the square root of 8 times x cubed. To simplify a square root, we need to factor the expression under the radical into perfect squares. Well, we notice that we have some factors because we're multiplying an 8 times an x cubed. However, 8 is not a perfect square because I cannot take the square root of 8 and get an integer. And x cubed is not a perfect square for reasons that we discussed in a previous video. If we try to take the square root of x cubed, that's the same as raising x cubed to the 1/2 power. And when raising a power to a power, we multiply the powers. So this is the same as x to the 3/2 power, because 3 times 1/2 is 3/2. Since we did not get an integer power, x cubed is not a perfect square. This means that we have some work to do. We actually have to factor the expression into perfect squares. We're going to factor the 8 into perfect square factors in the same way that we did when we were just simplifying square roots with numbers inside. We're going to do that by listing the factors of 8 or the perfect squares. I'm going to do that by listing the perfect squares. The perfect squares are 1, 4, 9, and once I hit 9, I know I've gone big enough. 9 is not a factor of 8. I know I've gone big enough because 9 is actually bigger than 8. Is 4 a factor of 8? Well, yes it is. So this means that 4 is a perfect square and it's a factor of 8. So I want to factor 8 so that 4 is a factor. because I want it to have a perfect square factor. I don't want to change the value of the radical, so I need to keep this so that it'll equal 8. So I need to multiply 4 by something that'll still give me 8. Well, that something is 2. 4 times 2 will give me 8. Next, x cubed is not a perfect square, so I need to factor that expression, x cubed, into something that is a perfect square. I want that to be the biggest possible perfect square. So what I'm going to do is I'm going to consider all of the exponents that I could factor it into, starting with the biggest. So I'm going to count down from x cubed. Is x squared a perfect square? Yes, it is, because if I take the square root of x squared, I will get x. So x squared is a perfect square. So I want to use x squared as one of my factors. Again, I don't want to change the value, so I still need an x cubed inside the radical sign. So in order to get x cubed, I would have to multiply x squared by x. Now, the exponent on x is actually 1. We usually don't write 1 as an exponent though, but let's take a look at what this tells us. When multiplying like bases, add the exponents. So this would give us 2 plus 1, which would be 3. So that's why we need to multiply by an x. But again, we usually don't write that exponent of 1 when we have x to the first power. Now I'm ready to apply the root of a product rule. The root of a product rule tells me that the root of a product is the same as taking the product of each of the roots. This gives me the square root of 4 times the square root of 2 times the square root, that should be an x squared there, times the square root of x squared, times the square root of x. Now I'm going to take the square root of all of the numbers that I can take the square root of. The square root of 4 is 2. I can't take the square root of 2. The square root of x squared is x, and I can't take the square root of x. Next, we usually write our answer so that all of the numbers that are not inside of a square root appear first. That would be the 2 and the x. And the numbers that are in a square root come at the end. I can do this because I have all multiplication. This is 2 times the square root of 2 times x times the square root of x. This is all multiplication. And the commutative property tells me that I can do multiplication in any order I'd like to. So I'm going to start by writing this factor of 2, and then all the other factors that are not in a square root. So that'll be like the x. And then I'll write all the factors that have square roots. That'll be the square root of 2 and the square root of x. And now what I'll need to do, this is not considered in simplest form because I have 2 radicals and they're being multiplied. So I should apply the product rule that states that the product of roots is the same as the root of the product. So I'm going to rewrite this as 2x. This doesn't change, but here we have a product of roots. So I'm going to write this as the root of the product, which will be 2x. This now is in simplest form.